So now we're going to talk about how we're going to lay out our center line of the road, which is basically the backbone of our subdivision. So our lots are going to come off perpendicular from the right-of-way line. Right now what I've done is I've drawn an extension off of the existing road from the previous project. So if I click on the existing center line of the roadway, you can see this radius is 50 feet. And based on our standards, we can have the minimum of a 50-foot radius. Typically, I do a 100-foot radius at the center line, but since the project next door to us has 50-foot radius, I'm going to use that. So what I've done is extended out the center line and offset my center line 25 on each side because the minimum right-of-way width is 50 feet. Again, going back to our codes, the minimum right-of-way width needs to be 50 feet. So we're going to keep a 50-foot radius, and our cul-de-sacs need to be a minimum radius at the right-of-way of 44 feet and a minimum of asphalt of 34 feet. So the right-of-way of a cul-de-sac is 44 feet. So when I'm doing this, I can come in here and just arbitrarily set a parcel line, or I'm sorry, set my center line and then set a circle for our cul-de-sac. So what I'm going to do is I'm going to bring the road down and then I'm going to turn it and have it go parallel to or perpendicular to this property line. So I'm going to draw a polyline. And I'm going to go from up here, and I'm going to turn my ortho on. If you actually look at the bearings down here, it's almost 90 degrees, so I'm going to just use it 90 degrees. So I'm going to fillet this with a radius of 50. All right, now I'm going to extend that to this line here, and I'm going to draw a circle of radius of a 44. Now, the radius of the 44 again is for our right-of-way line, and from that I'm going to also draw I'm going to draw a circle at the end point here of 100 feet because I don't want to draw a intersection that is near a curve. I typically don't like to put intersections of roadways onto curves, so I'm going to hit that. Now, these are where I'm going to have an intersection. So houses are going to be built along here. We'll have an intersection, and I am going to copy this from the end point here to the end point up here. Okay, so I have two roads so far, and I'm going to have roads coming off of this, possibly roads coming off of this center line. Now remember what I said. I'm going to go ahead and offset 25 feet on each side. This is going to be my right-of-way line. Now in the codes, what we were talking about before, where it says that the pavement at right angles at the internal to the subdivision, that should have been 25. Is 25 feet. What that's talking about is at the intersection here, if I trim this up, we'll get rid of these lines here, it is a fillet of a radius of 25 feet. Okay? Now, when I'm doing grading of this, we got to take a look at the highs and lows. So yeah, I just brought this road in, but I got to really think about what the elevations of the grounds are. So I drew this little sketch up of our site. So parcel grading. So up here is a high point of 87 feet, and down here is, oops, undo that. Down here in this area is a low point of 68 feet. And there's also low points on the north side and on the east side. So the average ground, if the high point's 87 and low point 68, the average ground's about a 77.5. What that means is I am going to have to cut the area up here and fill the area down in this area down here. So I'm going to have about, when I start to do my profile, the average ground elevation is going to be about a 77.5. We'll make it a 78 to make our math just a little bit simpler. So now we need to talk about what a grade profile is, or at least some of the grading when we lay out this lot. So I'm going to go ahead and show you some grading information when we tie into where we're placing our cul-de-sacs. So I'm going to go back to my cul-de-sac, my drawing. Now, if this grade here is a 68, and I'm going to have an average ground elevation of about a 78, that means from 68 to 78 is 10 feet. And if I do a 4-to-1 slope, I have to have at least 40 feet away from that edge. So I'll show you the sketch. This is what I'm thinking my cross section is going to look like. Wrong one. All right. If down here was the 68 and I'm coming up to a 78, so I'll go ahead and say up here is going to be, I'll put that in a different color. Up here is going to be a 78. Then what I'm going is from 78 to a 68. So that's 10 feet. And this slope here is typically a 4-to-1. So every 4 feet horizontal, I'm going to go 1 foot over. So that means I'm going to have to multiply by 4, and the distance from this point to this point back here has to be 40 feet. Okay, so with that, I'm going to go back to my drawing, and I know I'm going to offset that right-of-way line 40 feet. Okay, and by doing that, we need to take a look and understand that if the cul-de-sac is 34 and the right-of-way, that's this edge right here is the right-of-way, then inside from where the asphalt is of that center of that cul-de-sac to the outside is actually going to give us a 3-foot grass space back here, or maybe the sidewalk is way back here and it's not attached. Usually I would keep grass that you'd have a little bit of space here, either 3 to 5 feet, something so when somebody's walking on her, they don't completely fall off the back of the sidewalk down the hill, 10 feet rolling downhill. So I'm going to go back to my CAD drawing, and now I've got 40 feet away. So I'm going to move this to the end point here. Okay, that allows me, if I look at the distance, oops, not the radius. From here to here, yep, that's my 40 feet. Just double checking. Hate to draw all this and find out that I drew the wrong thing. So now I know exactly where my cul-de-sac needs to be so I can grade it down. So what I'm going to do is I'm going to trim this up. Go ahead and get rid of these. Fillet radius 25. Now the reason that it's not filleting is I have to p-edit and convert this into a polyline. So now I can p-edit. Fillet radius, fillet it. I say one thing and do another. All right, so now I've got the location of my Centerline. So I'm going to go ahead and now do the same thing up here. So this is an 84. So what I'll probably do is make a high point here and make this point even higher. So when I'm looking at the cross section of my road, then this point right here is that cul-de-sac going to the north. If this is 78 and I need this to drain, I have to figure out what the cross section of this area is. And I'll set a grade here. Now, I'll come uphill and set that. So back here, from here to here, we know that the sidewalk has to be at, so let's talk about that. We know the sidewalk has to be at 2% cross slope. And typically, the elevation difference from here to here is a half a foot, okay? And our grass areas are usually about 6%, okay? So I have 3 feet at 6%. I have 5 feet at 2%, and I've got a half a foot drop to this elevation here. All right, so what does that give us? So that means at 3 to 6% is 0.18 feet. 5 feet at 2% is 0.1 feet, and I've got a half a foot. So I've got 0.78 feet elevation between this point and this point. So I've got 78 minus 0.78. That's going to give 77.22. So this point right here at the edge of pavement is going to be 77.22 feet. Now, typically I said I always want 0.35%, and the whole purpose I'm doing all these calculations is because I've got to figure out how far away from here that I'm going to tie into that natural grade. So I need an elevation set here. So what I'm going to do is I'm going to draw a circle inside here, and I'm going to say radius of, oops, circle center radius 34. So I need the distance from this intersection point to this intersection point, 186.36 feet. So if I go back to my sketch, this distance here is 186.36 feet. So I'm going to go uphill 186, I'm going to do the math here, 186.36 times 0.0035, because I need to get it in percent. I am going to add 0.65 feet to that, plus 77.22. So this point right here needs to be approximately 77.87. Okay, what I did was I took the 77.22 feet at the curb, I added 0.0035 times 186.36 feet. That allowed me to get that 77.87. Now I'm going to have, when I go back here, back to my drawing, this elevation is going to be 77.87, and I need to get it to grade downward. So technically, let's see how long that line is. I'm going to turn my properties on. That line is 226.16 feet. So if I have 77.87 minus, basically, we're going to do 84, and so that's 6.13, and divide that by the 226.16, That's approximately 2.71%. So that's not bad. So this will be what I do. I'll show you the math here. Sorry, wrong one. So from this intersection, we said that we've got a 77.87 elevation, and we were going uphill to an 84, and that whole length was 226.16. So if I multiply that by 100, that's going to give me approximately 2.71%. So when I'm looking at the intersection of that road going north to our road that is going east-west, that slope is 2.71. That's not going to be exactly it, because when we go and do the slope, when we look at, wrong one, sorry about that. When we look at the intersection here, we have to do 2% down and then coming back up for our cross section. All right, so let me show you. Now, so we've got this set. So I'm going to move this, and I'm going to offset it 4 feet. That 44 foot offset at 4 feet. The reason is I said an 84, and it's actually a greater than an 84. So if I give myself 4 feet from the back of the right-of-way line, I should be able to tie into existing grade without a problem. All right, so I'm going to delete that one, and I'm going to trim this up. Delete these and change that, because this isn't a polyline anymore. I need to turn it into a polyline. Fillet radius 25. And now I have got my proposed project started. All right, so I'm going to stop here, and in the next video I'll actually talk about laying out the parcels for this project.